Hello, 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 and welcome to another episode of Mr. Boskin Does Some Math. Today we are doing illustrative math, grade 8, unit 7, lesson number 2, practice problems. First problem here says write each expression with a single exponent. So, quick review of how we do this. 10 to the 3 means 10 times 10 times 10. Times 10 to the 9 is 10 times 10 times 10 times 10 times 10 times 10 times 10. How many we got? 1, 2, 3, 4, 5, 7. Times 10 times 10. So 10 to the 3, which is 3 tenths, times 10 to the 9, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 tens and 9 tens is 10 to the power of, well, let's see how many we've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 10 to the power of 12. Hey, 9 plus 3 is 12. If we have the same base, 10 to the power of something, we can just add the exponents. Now this next one, this is a little trickier. There's no number there. We can't add the exponent if there isn't an exponent. Let me try doing what we did before. 10 times 10 to the 4th, which is 4 of them. 10 times 10 times 10 times 10. How many have we got? Well, we got that original one, and those 4 more, that's 10 to the 1, 2, 3, 4, 5. 10 to the 5. If there is no exponent, the exponent is 1. 4 plus 1 is 5. Okay, 10 to the 7, or 10 to the 10 times 10 to the 7 is 10 to the power of 10 plus 7 is 17. 10 to the 3 times 10 to the 3 is 10 to the 3 plus 3 is 6. 10 to the power of 5 times 10 to the power of 12. 5 plus 12 is 17. Uh-oh, we got triples. 6 plus 6 is 12. So these together we can think of as 10 to the 12. Times 10 to the 6. Well, now we just add that. 6 and 12 is 18. 6 plus 6 plus 6 is 18. Okay, what have we got next? A large rectangular swimming pool is 1,000 feet long, 100 feet wide, and 10 feet deep. The pool is filled to the top with water. What is the area of the surface of the water in the pool? So if we think about a pool, it looks like a rectangle, but if we're looking down from the top, the surface area is just this one side. We don't have to worry about the other sides. They're covered by the pool. We just want the surface area of the water in the pool. So we don't care how deep the pool is. We just care about how long and wide it is. So the surface area is 1,000 times 100, which is 100,000. 1,000 times 100 is 100,000. How much water does the pool hold? Ooh, we need units, we need units. Square feet. Surface area is measured in square units. Feet times feet. 100,000 square feet. Now, how much water does the pool hold? That's a volume question, so we need length times width times height. So we need the 1,000 feet long times 100 feet wide times 10 feet deep. which is $1,000,000 cubic feet. Express the answers to your previous two questions as powers of 10. Okay. 10 to the power of something, square feet, and 10 to the power of something, hey, you forgot the T, cubic feet. Now this one is 10 to the power of 4. Nope. 5. This one is 10 to the power of 6. Oop. I didn't think we were done. Here is a triangle. Hooray for triangles. Here's triangle ABC. Triangle DEF is similar to ABC, and the length of EF is 5 centimeters. So if ABC is similar to ABC is similar to DEF, and we know EF is 5 centimeters. What are the lengths of DE and DF in centimeters? Ooh, 5 times a half, or 10. 10 times a half is 5. 6 times a half is 3. And 8 times a half is 4. Because the scale they're similar, so there has to be a consistent scale factor, and the scale factor from 10 to 5 is 1/2. Elena and Jada distribute flyers for different advertising companies. Elena gets paid 65 cents for every 10 flyers she distributes, and Jada gets paid 75 cents for every 12 flyers she distributes. Draw graphs on the coordinate plane representing total amount each of them earned, Y, after distributing X flyers. Use the graph to decide who got paid more after distributing 14 flyers. So, we want to make sure we have 14 flyers on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 14 lines. Let's count by ones. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And these are flyers. Now, on our other axis, we want money. They're getting like 65 cents for 10, 75 cents for every 12, which means we don't need to go up much more than $1. Let's count by 10 cents. 5 cents might get us there. No, let's go 10 cents. 10, 20, 30, 40, 50, 60, 70, 80, 90, $1. $1.10, $1.20. We're not going to have to go any higher than that. Now, let me zoom out so we can fit everything on our nice graph. We know for both of them, you distribute 0, you get paid 0. They're both going through the origin. Elena gets 65 cents for every 10 flyers. So 10 flyers goes with 65 cents. Jada gets paid 75 cents for every 12. So 12 flyers is 75 cents. So that's close to basically the same thing. Which means this would probably work better if I had had a ruler. But I know for Elena, they get 65 cents for every 10 flyers. It's a lousy looking 6, which is 65 divided by 10 is 6.5. And who's the other one? Jada gets paid 75 cents for every 12. 75 cents for every 12 is 6.25. So, who gets paid more? Elena gets paid more. Jada gets paid slightly less, which means that graph should have looked kind of more like that. Who gets paid more? Elena. That is our last one. This has been another episode of Mr. Boskin Does Some Math. Thanks for watching. We'll see you next time.